Welcome again, Wildcats, to Thursday, August 31st, and we're going to be learning about sets of numbers and notation, and that's going to be on page 2 of your notes. So if you would, update your table of contents, which might require you to pause it, but if you can write fast, you don't have to pause. All right, either way, at this point, I'm assuming you got your table of contents updated, so let's take a look at our notes. All right. So today we're looking at sets of numbers and notation. That's on page 2 in your journal. Okay. All right. So let's look at the vocabulary first. Okay. All right. So we have a set, which is a collection or group, an element, an item in a set, a subset, a set within a set, an empty set, which is a null set without elements, a finite set, which is a limited number of elements, an infinite set, which is an unlimited number of elements. All right, so some of you new to the video world or the internet world, the internet's not that new, videos aren't that new. So let me try to help you kind of walk you through this video. So what you're probably going to want to do is I'm going to read through some of the notes, and then I'm going to leave the paper there, which is a good time to pause it, and then you can write everything down. And then once you have it written down, you're going to unpause and then continue the video, okay? So at this point, pause the video, update the vocabulary. All right, so now your vocabulary is updated. I assume you've paused it, so let's now move into notation. All right, notation. So you have roster or list, which is also known as set builder notation. Okay, so examples of that, example 1, you have alphabet. Example 2, you have positive even numbers. Okay, now when in roster, and I wrote it, but I want to make sure you understand, whenever you do roster, you have to use these funny looking parentheses, which if somebody can think about it, tell me the name of that, because I'd be fascinated to know what the specific name of those parentheses are. But you have to use that type of parentheses for a roster or set builder notation. Okay. All right. Inequality notation, which uses inequality symbols. Okay, which are less than, greater than, less than or equal to, greater than or equal to. Okay. Now, what a lot of people don't understand is that's when you read it from left to right. Okay. But if I turn this paper upside down, now this says less than or equal to, this says greater than or equal to, this says less than, and this says greater than, because now I'm reading it from right to left. Okay, so that's why I didn't name these inequality symbols, because they mean both depending on which direction you read, from left to right or right to left. All right, some examples of that. Example 3, you have x less than, and now I'm reading this from left to right. X is less than 2, or x is greater than or equal to 5. Now, if I read example 3 from the right, that says 5 less than or equal to x, or 2 greater than x. Now, we normally don't read from the right, but mathematically that is correct if you read it from the right, okay? All right, example 4, that says -1 less than or equal to x less than 2. Now, if you read it from the right, that says 2 greater than x, where x is greater than or equal to -1. All right, so at this point, you want to pause the video and update your roster and inequality notes. All right, so again, and I'm not going to do this through all the videos. Probably even after this video, I'm not going to say, hey, pause the video and so on, but I just want you to kind of get used to it in this video, okay? All right, so last we have interval notation, which is all symbols, okay? And we're looking at it, I've kind of broken them up into 3 sections, okay? So you have, when you have parentheses, you use no line underneath the inequalities, okay? And these mean not equal, which is an open circle, okay? Now, if you use brackets, that means equal, which means you have the line underneath the inequality, and it's a solid dot, okay, or a filled dot, okay? This means or, and that means and, okay? Some examples of this are example 5, and you'll notice that I kind of, this went a little long, so I broke a piece from there, okay? This says parentheses negative infinity, and it's a parentheses because you can never include infinity, okay? So you have from negative infinity to 2, or 5, including 5, that's equal to 5, to infinity. Okay? In example 6, you have between -1 and 2, including equal to -1, but not including 2, or not equal to 2. Okay? All right, so if you would, finish those notes up. All right, so I assume your notes are completed. Make sure you're keeping this in your 3-reading binder. And remember that you have, so your journal should kind of look like this. You have your table of contents, okay? Page 1, which I don't have in the video, should be right behind this, which is your syllabus. And then you'll see these lines mean that this not in the journal. And then behind the syllabus will be the notes that you just took, okay? All right, so the first part of sets of numbers is kind of going through kind of the history of numbers and how the set of numbers works, okay? So we're going to kind of start out where numbers started, okay? They started with natural numbers. Okay? Now, natural numbers are 1, 2, 3, ... Okay? They're called natural because it came natural to early societies counting, okay? Now, the next, and you'll notice that natural numbers are inside of whole numbers, and that's how this works. I'm just going to use I'm going to use a number symbol. Whole numbers are, and that is written with the number. Notice how a natural number you use the letter N. Well, whole numbers you use the letter W. That represents. So if you write W, you're saying that's whole numbers. Okay. Now whole numbers, okay, include 0. Okay. Now you'll notice natural numbers are included in whole numbers, but whole numbers are not included in natural. That's how this works, okay? And whole numbers, see, again, not natural. 0 was this, believe it or not, was this crazy idea how to represent nothing. They didn't know how to do it. They didn't really even understand what nothing meant, okay? All right, but then when they discovered it, it became part of our number sets, okay? Now the next is integers, which is represented by the letter Z. Okay. Now, once they started to understand nothing, then they came to start to understand, well, what are negative numbers? Because they would borrow from people, and they would realize, wait a second, if someone's borrowed, then they owe me. How do you represent kind of owing something or debt? And that's represented by negative. Okay. And so integers include now negatives and positives. But something important about integers is that there are no decimals and no fractions. Which, by the way, you'll notice that as a math person, it drives me crazy to not have this organized and neat and like really cool looking. So if you're out there taking notes and you realize that your notes are better than mine, let's negotiate. I might be able to negotiate some prices. Maybe I'll buy your notes if they're better than mine. So keep that in mind. Come to me, negotiate, and say, man, you know what, Mr. Luke, my notes are better. You know what, I might give you $1 or $2 for your notes. 5 if they're the most phenomenal notes I've ever seen in my life. Okay, so keep that in mind as you're taking notes. Okay. All right. So next came rational numbers. And that's represented by Q. Now, rational numbers are positive, negative, fractions, and decimals. And I'm not quite sure like how fractions and decimals came about. It'd be something to look into, and maybe if you can look into, tell me, hey, by the way, Mr. Luke, I saw your video and I was reading about it, and this is why and how fractions and decimals came into the number world. Okay. Now, something to know about rationals is the decimals and fractions are terminating. Okay. or repeating. Now, something you'll notice is that a natural number can be rational because you can do 1 divided by 1, 2 divided by 1, 3 divided by 1, which makes it a fraction. Okay, whole numbers, again, can be, so this is how this works, is these numbers, natural number can be a whole integer rational, but a rational can't always and sometimes be a natural number. So some of them can be, but not all of them. And that's kind of how this works, okay? All right, and all these numbers are included in the world which we call real numbers, or noted as a double R, okay? And real numbers are basically all numbers on a number line. Okay? Now you'll notice that, which basically says, in essence, is almost every number in the entire world, okay? But you'll notice that there's a circle here that's separate, okay? And we call those irrational numbers. Okay? Which are non-terminating numbers. Okay? Some examples of that are pi. Pi, and people have been looking at this, but it goes into hundreds and millions of digits, okay? Square root of 2 and square root of 5. So if you put these numbers in your calculator, you'll see that the decimal doesn't terminate. It just keeps going on and on and on and on forever. Now, the calculator's programming is limited, but if you were to get like a supercomputer, you put in square root of 2, the decimal is just going to go on and on and on, and it's not going to be repeating, okay? All right, so that is all the numbers in the world, okay? So again, if you would finish up your notes. Now, this is actually going to go in your journal, and you're probably going to want to turn it, and just know that since it's all under the number, basically, you can almost call them sections, but section 2, so I'm going to put this under 2, okay? All right. So now let's look at some examples. All right, now this is where I noticed from my first year doing flip videos is where the most frustration occurred. Okay, and we have to have a real conversation right now. Okay, I'm going to go over the examples, not with the expectation that you understand them and then you finish all the assignment before you come to class. All I want you to do is watch the examples, and if you get it, then write down what you get, okay, and then you can go forward. But if you watch me explain something and you say, man, you know what? I heard them, but I didn't understand it. What you might do is put a little question mark and put a little note. This is what I don't understand, so that when you come into class, then you can ask me in class and we can have the discussion and I can explain it. Because I'm going to explain that. I call it the overlap, okay? I'm going to explain these examples in video, but I'm also going to explain them in class as needed, okay? So if you write down your note and say, man, I need number 1, okay, then I'm going to go over it. But if no one in class needs number 1, and even if it's one person that needs it, I'll go over it. But if no one needs it, then we're not going to go over it, okay? But that's why it's important for you to know, hey, I had a question on this, okay? All right, so let's look at, and I think in the video, I'm just going to look at 1, 2, and 4, okay? Now, if after I go over 1, 3, and 4, you get it, go ahead and feel free to finish the assignment. But if you don't, again, that's where you write the little question mark or a little note to yourself, and then remember that you're going to come to class. Because remember, the point of me going over those numbers is just for you to be familiar with them so we can start that conversation when you come into class, okay? All right, so inequality notation, which that's what this is, but now it wants interval notation. So I'm going to actually go to my notes, and interval notation in the notes says it's all symbols. That includes the parentheses and brackets, okay? So the way this works is you always go from left to right. So this says x is less than 4. So all the numbers less than 4 are negative infinity. So we're coming from the left, coming from negative infinity, and we're going to stop at 4. Okay? And that's a bracket. Oh, that's not a bracket. Well, let me back up. That was about to be a mistake. And you might ask yourself, wait, what mistake did I make? Well, the mistake I made was there's no line underneath, so it's parentheses. Okay? So now on the number line, we're coming from negative infinity and we stop at 4, but it doesn't include 4, so it's an open circle. Okay? All right. So again, remember, as you watch the video, you can pause it, and then you can get caught up, and you can take time to make this much neater and take your time, and then, or you can just follow as I go. Okay? All right, number 3. Okay? So here we have x is between negative 3 and 5. Okay, so we start at negative 3 because we start from the left, but that's a bracket because there's a line underneath, negative 3, comma, to 5, which is a parentheses because there's no line underneath. And what this is saying is x is every number greater than or equal to negative 3, but less than 5. So at negative 3, it's a closed dot, okay? And then we have all the numbers until we get to 5, and it doesn't include 5, so it's an open circle. Okay? Now at this point, look at your notes and see if you can try number 4 on your own. All right. Now, when I say that, what you want to do is when I say try something, pause the video and then continue it, okay? All right, so number 4. I don't know if I said that right. No, let me say it again. You pause the video, you try it on your own, and then you click play to see if what you did is correct, and you'll know because I'm going to go over it after you pause it, okay? All right, so it says x is less than negative 3, okay? So, again, we can start from the left, so we're going from negative infinity, let's just say less than or equal to, negative infinity to negative 3, but it's a bracket, okay, because it includes negative 3. And so, or, I know there's a symbol for that. It's on the notes. Okay, so or is a u, and then we're coming from x is greater than 2. So we start with 2, and we go to infinity. All right, and so then we're coming from negative infinity to negative 3. So that's going to be a filled dot. And so that's every number from negative infinity to negative 3. Or, and then, so we start at 2, but it doesn't include 2 because there's no line underneath. So open circle, and that's 2 to infinity. All right, so at this point, if you feel like you can finish 1 through 11, please do. But again, remember, you can write a little note or put a question mark that says, you know what, I heard your explanation, but I still didn't really understand it. And so I have a question here. So you might not, and just for future reference, if you might watch and then write. So if you watch the video of the problem and you get it, write it down. But if you don't, leave it blank so we can go over it together, okay? All right, now with that, turn the page over. All right, so here, this, I'm not even going to go over any of it. So don't even stress about this until we come to class because I've thought about it. I don't even want to explain it in the video because I don't think it will be productive. I think it's more productive if we explain, just start right then and there in class when we have the discussion because I think it's easier to explain and really understand when you're in a in-class setting, okay? Now I'm looking at here, we're at the 19-minute mark or so. And that's a little longer, okay? And the reason it is because I stopped to explain kind of how the video process would work in this class. Just know that after this video, I'm just going to basically skip that, and that should bring it down by 3 or 4 minutes to on average about a 15-minute video, or even sometimes 5. So, so just so you know with that. But I look forward to finishing this assignment with y'all tomorrow. And with that, have a wonderful Wildcat